apparently using that for very lots of generation. So with that, I'll take it to Xi.
Thank you, Ellen, for the introduction. Yeah, it's really great to meet everyone here. Yeah, as Ellen introduced, I will. How long do I have, by the way?
Until 2:50.
2:50. Okay, that's plenty of time. Yeah. Yeah. Okay. Sounds great. Yeah, I will give an introduction about the AG2 effort. It's open source agent OS, and I will talk about the key kind of design point. How do I move the forward slide?
To the front of the file.
It doesn't move. Oh, okay. Thank you. Yeah, I'll talk about the design principles, the use cases, and why use AG2 to build your agents and agentic applications. I will start from. By the way, how many of you have heard about AutoGen? Could you raise your hand? Okay, great. Yeah, so majority of them. So that's made it easier. So I guess I only need to talk about the major updates from AutoGen to AG2. Probably you haven't heard about AG2 that much. AG2 is basically a fork. I will talk about the history and the origin of this. Yeah, but I will start from the beginning. Like when we started building AutoGen, what is the thinking process and what kind of vision we had. So starting from about 2 years ago, we saw the very powerful generative techniques like GPT models. They can generate the high quality content and like text and image. And so the question we were thinking of is, what are the future AI applications like, and how do we empower developers to build them with this powerful technique? How do we push the limit and make the maximize the utility of these models and build really useful applications for every domain? So that's the key questions to think about. And after some exploration, we decided to make early bet on the agentic AI. At that time, many people still had doubts, but it's amazing to see how quickly it has become more and more recognized that this is the future, and many people are building AI nowadays. There's no kind of consensus of the exact definition that in my vision, these agents are very capable of executing complex tasks on behalf of human, and there are multiple reasons we want to make a bet. The first two reasons are probably obvious to most of our people. They have a very natural interface to communicate with human as a strong, useful interface, new interface. And the second is they can make the capability much stronger. So not just using model to generate some content, but make multiple steps and start like, for example, doing tasks all the way from beginning to the end, finish them, and you can imagine also even build an entire company and simulate the roles of the human in the big organization and accomplish very complex tasks. But the third reason is maybe less talked about. That is the architecture point of view. So if we think one step further, so in future when you are able to build many of these agents doing all different kind of things, if you can also make them interact and together either collaborate or cooperate, they can achieve even more. So, but that requires us to think about agent as a fundamental kind of a new software unit. So instead of like using functional programming, object-oriented programming, this agent-oriented programming can be an even higher level abstraction of building software. So that's a bigger implication. So let me show you a quick demo about.
Let's jump into a live demo of one of the key features of AG2 0.6 release, real-time agent.
About a new feature that combines these several elements.
Welcome to Agentic Airways. Please wait while we connect your call to the AI voice assistant. Okay, you can start talking.
Can you please provide more details about your request?
I would like to cancel my flight.
Your request to cancel the booking has been noted. I can assist you with canceling your booking. Could you please confirm which flight you are asking to cancel?
Flight 123.
You've confirmed that you'd like to cancel flight 123. Just to confirm, you're asking to cancel flight 123. Is that correct?
Yes.
You've confirmed that you want to cancel flight 123. I'll go ahead and process that cancellation for you. Thank you for confirming. Would you like a refund for your ticket, or would you prefer to receive flight credits?
Flight credits.
You've chosen to receive flight credits. I'll proceed with processing that for you. Your flight credits have been successfully processed and will be available in the next 15 minutes. If you have no further questions, I will consider this case resolved. Thank you for reaching out and have a great day.
Thank you. Goodbye.
Goodbye. Have a great day.
Great. That's a real-time agent in action. And that agent brings real-time voice APIs to an agent within AG2, allowing you to converse with your workflow. In this demo, we've used OpenAI's real-time.
So yeah, so I have let me explain a little bit about what you saw on the screen. So what you heard is about real-time voice agent talking with the user in real-time voice. You can use any kind of API as backend OpenAI or Gemini API. And but you also saw some messages, right? They are from the different sub-agents that perform specific tasks. In this example, we have agents that do triaging, that can handle flight cancellation or flight modification, and each of them will perform certain functionality and hand over to other agents when needed. So this is rough architecture about how they work together. We have this real-time agent that is in charge of have this natural interface with communication with the user in real time, but the user don't need to know that there are multiple backend agents working behind the scene. But they really work together and can handle more complex tasks. So this is a very good way to kind of further enhance your system's capability in unbounded way, because you can add more agents if you need to extend it or remove agents, but without changing the existing functionality. So this is a big benefit of making modular and make it easy to extend the functionality. And what you saw is one particular example of one kind of user experience. Let's also check a different example so that we get more comprehensive picture.
Okay, I will repeat the question to you and then get the answer from you. The question is, what is the topic of your request?
Can you help me cancel the flight, please?
Okay, so the topic of your request is canceling a flight. Okay, I have set the answer. Is there anything else I can help you with?
If you can just help me cancel the flight, that'd be great.
Okay, I understand. I can help you with that. Can you please provide me with the flight details?
Yep, it's flight number 1919.
Okay, I will repeat the question to you and then get the answer from you. The question is, which flight would you like to cancel? Please provide the flight number or any other identifying information.
Flight number 1919.
Okay, so you want to cancel flight number 1919. Okay, I have set the answer. Is there anything else I can help you with? Okay, I will repeat the question to you and then get the answer from you. The question is this the flight you initially contacted us about?
Yes, it is.
Okay, so the answer is yes. Okay, I have set the answer. I will now proceed to cancel flight number 1919 for you. Is there anything else I can help you with today? Okay, I will repeat the question to you and then get the answer from you. The question is, do you prefer a refund or flight credits for your canceled flight?
Refund, please.
Okay, you prefer a refund. Okay, I have set the answer. Is there anything else I can help you with? Okay, I will repeat the question to you and then get the answer from you.
Thank you
The
very
question
much.
is,
Did you notice anything different? What's your feeling? Compare this demo versus the previous one. Do you feel this is better or worse? Yeah. Yeah, good catch. Yeah. These two examples use slightly different approach, architecture, or models and prompts. So, but the result is there's a big difference, right, in terms of user experience. Even the previous demo has some problem, some issue, but maybe this one is more obvious. And can you guess why? Why is this keep saying I repeat the question and get answers from you, or things like that? Yeah. So. Yeah, but did you know why is there any kind of developer? So from developer point of view, how do we kind of understand how to solve this problem, or what's the root cause and what modification do I need to make the change to the system? Is there any guess about anything wrong the developer did? Yeah, so this is related to if I use this picture to explain, this is related to like how we get these multiple agents working together. Because for the real-time agent to correctly pass information from other agents to the user, currently like the existing API doesn't really support that. So we need to kind of use some specific way to instruct these different agents. And for the real-time agent, the instruction given to the real-time agent in the second example is do not, I mean, always repeat the question from the user. But here the user is actually the other agents, because from the existing like API, we can only instruct the model to talk to the user, and they have no notion of like other agents and so on. So we have here we basically ask the real-time agent to repeat the questions received from other DOM agent. For example, flight cancellation agent needs to get the flight number, so it asks the real-time agent to ask user for that question. So real-time agent now is playing the role of like repeating the question from other agents and then ask the user, and so it's kind of serving as a bridge. But this instruction is provided in the system message to the live API of the agent, so it's not supposed to be exposed to the user. But just for some reason, maybe this particular model is not able to hide that instruction, and instead it's like speaking that out loud, right? So that causes the undesirable user experience. So my main point is this: it's while it's promising to say the future of software is agentic, and we can offer very strong capability and very good experience to users, it's not that easy to deliver them. So there are lots of issues. In general, developer needs to make a lot of like design choices and optimizations in terms of like what model to use or the prompt to use, how do you connect these models and tools and humans in a nice way, and optimize for the different metrics. In general, they have a very large design space to navigate and find out a good design. And that's a problem we want to solve with Agent OS. And we want to build some common infrastructure that allow them to quickly navigate the space and find a good design and build really good application quickly. And that's the kind of fundamental problem we're trying to solve. In general, there are multiple kind of criteria a good AI agent framework should satisfy to meet all the promises I mentioned. I will go over some of them. The first one is, as you already noticed and many people observed, using model alone is often not enough to deliver this strong agentic behavior. And we often need to use multiple models or tools or like humans of different roles to build a compound AI system. And but it's very hard to reason about these different type of components if we have to reason about each type of them. So having a unified abstraction has the benefits of simplifying that reasoning process. If we can model all these different type of entities just as agents, and then simplifies the thinking process to just think about how to orchestrate these multiple agents working together, and then make them interact nicely. So the next important question is, how do we allow them to allow developers to easily orchestrate these multiple agents in an intuitive way? And also we need to support a lot of different cases. Sometimes they want to use more static flows that follow peacefully about some fixed logic. Some others, they want the agents to make more decisions and make more dynamic workflows. And similarly, sometimes they want to use natural language to instruct agents to be more flexible. Other times they want to use program language to have more control. And there are also considerations like, do we share the context among all the agents, or do we have certain isolations to make the agent compete or cooperate? Do we have a centralized or decentralized design? And how do we balance like human intervention versus automation, all sorts of questions they need to address. And after we design this framework, we also need to check whether it can support all the emerging AI agentic design patterns, like conversations, both between human and agents and between agents, advanced prompting, reasoning techniques, planning techniques, tool using, and the integration of multiple models, modalities, and memories, and so on. But it's very hard to think about all these different requirements and have one framework that can address all the future techniques. So we can usually we want to start from like first order principles, start from minimal set of concepts, and make sure that's solid, and make sure it can accommodate all the future emerging patterns. And the different people will have different starting design points. For us, we chose this multi-agent conversation as a central mechanism, and make that as an essential concepts. But it turns out it can also accommodate all these other design patterns very nicely, and as a very generic technique, a very generic kind of framework to incorporate all the future kind of technology developments that has been proven since the past 2 years. So now I want to mention a little bit about the history. And when we started this project, we built this AutoGen subpackage inside another open source project called Flamo. That's a project I started like 6 years ago about AutoML and model selection. And in roughly kind of August 2023, we wrote the paper. We didn't plan to write the paper in the beginning, but my intern in summer have done some follow-up work. So he really needs a paper to cite. So then Qing and myself decided to kind of put it on archive, and in like 2 months later, we moved it to move the repo to a standalone repo on GitHub, and that's where it got huge interest, and the very large communities started to be built around that time. And quickly it got like a lot of recognition and usage. And what made me most kind of proud is most excited is to see how many kind of diverse applications have been built by both enterprise companies and startup companies, and also scientists. And also offer a course on debugging.ai called AI Agent Design Patterns with AutoGen. Yeah. So but since then the AutoGen has evolved a lot. But the like the key concept has not changed. I will in the next few slides I will discuss the kind of the key essential concept. But just to quickly mention, recently we also made a fork called AG2 to make sure this continues to be a community-driven effort, and to quickly build towards this vision of like open source agent OS. So now the community is working actively on the AG2. As I mentioned, a lot of things have evolved, but the key concept has not changed. We want developers to think about any arbitrarily complex applications in simply 2 steps. The first is to define agents in different roles, and the second step is to get them to talk using conversation programming. Here, the agent abstraction is very generic. One agent can use different backends to perform similar like an interface. They will follow the similar interface to generate messages, generate replies to others when they receive the messages. And the difference is how they generate the replies. They can use the language model to do it, or they can use other non-language model tools or human inputs. These are the primitive agents that do relatively simple things. But how you kind of construct stronger agents? The answer is that you can combine these agents, like make them perform conversations in all different patterns. But eventually you can also construct one agent that put these multiple agent conversations inside, but to the other users or agents, that a single agent is perceived as a strong entity with very strong power. So we see a similar example in the real-time agent example. From the user's point of view, it's just talking to one agent, but there can actually be multiple sub-agents behind the scene to perform conversations. AG2 offers many flexible conversation programming patterns, including sequential chats, message chat, group chat, and recently it's a Swarm pattern inspired by OpenAI Swarm framework. So yeah, so that's basically it. So the minimal kind of sound concepts are very simple, but it's able to kind of add a lot of like rich features, which support all the agentic design patterns just using that concept. Here, if you go to the ag2.ai website, you will find a YouTube channel that talks about the recent highlights and recent releases from the AG2. Here I summarize the majority of the features in the 3 categories. Like in the interface, you already see the real-time agent. I will mention the cabinet agent towards the end of the talk. And there's a lot of like specific agents with strong capabilities like agentic RAG, or reasoning, or web surfing and deep research. Yeah, so and this communication engine is one example of the useful architecture you can use to build like a community management on different platforms like Telegram, WhatsApp, and so on, and Discord. What the communities have been using these new features for. So this is one example of community built no-code UI interface using AG2 called Wadis. So it allows you to use the features in the framework without doing actual coding. So you can just create boxes, drag and drop, and configure your agents, and use all the different composition patterns to make them work together. And this particular example is one user of Wadis, who is a journal editor. They want to use the agent to help them decide who should be the right reviewer. So they need to handle a lot of like consideration like conflict of interest, coverage of different expertise, and so on. And the agents are able to check several different criteria. Each of them perform specific checking and eventually make a suggestion. So that's just a simple task automated for someone who may not necessarily be like a proficient in like coding and programming. And here's another example of a solopreneur who has been building agents to automate a lot of tasks, including like email processing, Google Drive calendar handling, project management, and web task automation, and many more like YouTube transcript downloads and so on. So because this is extremely useful for the solopreneurs because they need to like wear many hats and perform many different tasks, but time is the most valuable source. So this experiment is still going on. We have still see a lot of people who traditionally may not be that good at programming, but now they're able to even build this agent to automate things for them. So in the next few in the rest of the talk, I want to quickly mention several reasons about why AG2 is a very strong framework to use. Question? Yeah. Yeah.
How easy or hard have been consequently found to evaluate these agents, and what are the major bottlenecks? Like, given that you are like you're basically having exposure to an entire community building agents, what are the key challenges that you're seeing as people are putting them together, like based on your experience? Not so much about AG2, but more about just the
Yeah, in general, I think the biggest question is for a particular task, what is the optimal multi-agent topology to use, including like how many agents do you have, and what is the role, should be the roles, how do you decompose the task into several agents, and in what particular interaction mode they should have. So it's still a big design space, but although if compared to the previous, like you have to reason about the low level entities like the models, tools, and so on. The agent abstraction is a little bit easier to reason about, but still like a big design space. We have done some work about how to automate that in the beginning, but it's just the beginning of doing it. In general, just how you build the optimal solution for your application of many kind of that meet your all the criteria, including the quality success rate is really the first consideration. People want to make sure the agent can indeed finish the task faithfully and follow intention. That is already a step that many people struggle. Like they often go off the rail and have a wrong understanding of intention and or not finish the task with high quality. And then, but after that, people also need to kind of optimize for cost, latency, and many other metrics. So a lot of optimizable choices. Yeah, so I'll mention some of the research progress towards solving some of the problems. Yeah, yeah,
How would you?
yeah. Mhm. Yeah, this is very good question. Earlier, we did some work on agent eval that we built AG2 agents that can help us to understand the agent behaviors by looking at the logs and looking at what exactly happens in the whole process and suggest some criteria to break down the evaluation. Let's say that initially you just want to have a math problem solving task, but that task can be further broken down by how good is the understanding of the problem, how good is the choice of the solution, what's the calculation accuracy, and so on, right? You can evaluate in sub dimensions, and the agent is actually able to provide that breakdown instead of the human need to think about how to break it down. And then the agent is able to also score the performance of the agents against each dimension and give you some insights. That's one um, um, earlier effort, and recently we did another work that is able to evaluate the multi-agent system so that it can try to identify if things go wrong, which agent is one to be responsible, and at which step they make a mistake for the first time. Yeah. Mhm. Yeah. Yeah, that's right. Log analysis. But I think we can be more creative. Well, I've seen some use cases of like automated the testing, very similar to the second project I think demoed. They leverage the web navigation capability of agents to automatically think about the steps to operate the software or operate on the web and try to find bugs and try to find unexpected behaviors of the software or the website. And similarly, you can use agents. You can build agents to proactively think about what are potential weaknesses of an existing system and try to like simulate the user's behavior of all different kinds. And I think that's very powerful because if we ask a human to do this testing, we have to recruit a lot of human and spend a lot of like resources doing that. And also need to have people with diverse background to have best coverage. But now you can instruct agents to kind of do that simulation and also let them play the role of all kinds of different users, give them different characteristics to simulate, and then leverage the agent capability to actually operate these system, right? So that's one of the very important, very kind of early scenarios I designed AutoGen for. I envision that many steps that currently involve human participant and very expensive steps can be potentially automated by agents. So yeah, I want to expand. Yeah, please. Yeah.
You're responsible for things like this.
I think that's a big question. So we put a lot of considerations in the initial design. For example, we allow every agent to be configured as human in loop. So they the agent by default, for example, will ask human input before they generate any reply. So if the human provides the input, then agent will simply pass the input to other agents instead of generating reply by themselves. Only if the human skips that, the human will try to automatically generate. And not all the agents are using language models. Some agents can use tools that have more controllability. So they will only perform actions within the provided scope. And similarly, if you use building like tool execution versus code execution, the tool two use is more scoped, and code execution is more open. So people need to make trade-offs. Yeah, so there are small consideration like designs choices like that, but still I think it's not it's still an open question, right? I've seen efforts of like building agents to do either red teaming or do like auto defense that can you can build a team of agents that check the a request from user or from other agents before generating any response. And if it's not safe, just to prevent the other agent to even try to generate a response. I've seen like that, and also other agents like other example like people build agents uh, kind of simulate the jailbreaking process, and before we deliver a production system, we can first use that agent to do all sort of like internal testing, and if find problems, we need to enhance the system and then test again and until like most of the so it's very hard to find any problem. Yeah, so there are some examples, but I think it's still a big open question, big open area. Yeah. Okay. So yeah, so let me maybe talk about first of all about the diverse and specific use cases. That's one I think one reason AG2 is very good at allowing users of all different backgrounds and different domains to experiment with their ideas. So we've seen strong enterprise interest from pretty much every industry vertical, and also over time more and more usage and contributions from different organizations. And it's hard to kind of go all of them, but we're trying to curate more and more such use cases in a repo called Build with AG2, and we'll add a lot more content. Right now it's still very preliminary and a very small coverage. But here's like a selection of like example production use cases, which are I think very interesting because it span across a lot of different domains. It's from like autonomous trading, chip design, customer support, cybersecurity, data engineering, and also to like finance, investment, market research, patient support, healthcare, like and software testing, which is one I mentioned earlier. I will maybe select a few of them to expand. And the India use case is very interesting. They have been using it for chip design, so I'm excited to see similar interest here. And they have used AG2 for multiple like very time-consuming tasks for human designers. And for two of them, they're already using for production. And for the third one, it's a very lot coding and debugging. It's a very hard task, and but they also generate very impressive results. For example, the table shows they can improve the model's performance from about 60% to about 90%. So that's big jump after using agents. And for the other two, for the first two use cases, they reduce the time of human designer from days or weeks to 7 minutes, and the change right from using model to agents is also dramatic. Like for example, in the second example, they improve the performance from around 40 to 70% to 100%, like perfect accuracy, and with just a few iterations. They're able to kind of leverage the human expertise and just give the agents more kind of guided instructions to achieve that goal. It's quite interesting how they achieve that. And chip design, yeah, go on. These are the three tasks, and the first two are in production, and the third one is more research, doing more research. Yeah. And chip design is just one particular example of like very hard kind of a engineering domain that can benefit from agents, but there are many more. So like there's one group from MIT who have done these multiple scientific use cases like since maybe around 1 year ago, and they have done like protein design, material design, alloy design, and recently general sign agents that's able to navigate a large ontology knowledge graph and generate very good scientific hypotheses that connect on seemingly unrelated domains like biology, architecture, semiconductor, and music, and often do a better job than human scientists. And yeah, I know recently we have this co-scientist do work also very impressive, but this community effort has started longer than 1 year ago, and results very impressive. And another example is from Cambridge that uses AG2 to build self-driving cosmological laboratories. And they use AG2 to analyze very large data set for cosmology collected from all the telescopes about the universe and so on. And then analyze, for example, the background, like microwave background radiation, and understand secrets of the universe. So they also reduce the answer time a lot, and can reduce from a full day of work to just like 10-ish seconds. So that's also a big benefit. And recently they also leveraged the new features in AG2 to further make agents memorize lessons from past tasks and improve over time, and gradually also make it more automated. And not only in natural science, but also in like social science, I've been using AG2 to simulate the social behaviors, and for example, study how to what's the most effective way to have multiple agents working together to solve a complex. Is it better to have a leader, or just make them self-organized? They can answer some questions and validate some hypotheses like that. And there are also kind of examples from like startups.
Hi, I'm Justin, co-founder and head of technology at Better Future Labs. Our startup studio founds and invests in new technology.
I want to show you this one because this is like similar to the deep research kind of product recently from OpenAI and others. But again, this community has been doing similar kind of stuff longer than 1 year ago, and this is a particular example of that. Using agent to
teams of analysts to research and validate investment opportunities. The process of analyzing things like a company's addressable market size, their competitive environment, and more abstract concepts like the feasibility of building technology is a slow, somewhat repetitive, and an expensive process. So instead of hiring a new team, we built one. We modeled our teams of agents after real consulting teams. So there are managing directors leading each research area, research managers creating tasks and reviewing work, and analysts actually conducting the research. Here's a look at our competitive landscape team, analyzing an idea called Thunderdome. The managing director starts by creating the research objectives for the team.
Team heads up. We need to dig into the product Thunderdome within the AI hiring space. Here's what we're after. Competitor intel. What are they offering and how does it stack up? Pricing. How much are they charging and what's their model? Market insights. How big is the market and what's its value estimated to be?
In response, our eager analyst immediately begins to work on the request and comes back with initial research.
Hey, here are the competitors I found. TestGorilla offers an AI test to evaluate candidates' understanding of core AI concepts and their ability to solve AI tasks. Skillspace AI is a platform for evaluating developers. It includes challenges and project-based evaluations. I also found Glider AI.
But our manager has something to say about this. It critiques the work and provides guidance on how to improve the research. By the way, sounds like the manager may be having a bad day.
Researcher, this is missing the mark in your competitor analysis. I'm not seeing any specific details of how their offerings stand against Thunderdome. Use platforms like Bloomberg, Statista, IBIS World for reports which can help. I also need the specific funding amount details for Thunderdome and its main competitors. If Crunchbase and PitchBook access is limited, you need to get creative. Look at SEC filings or use databases like Prico. Lastly, your evaluation of competitor aggressiveness is non-existent. Look for market share data, examine their market strategies, and articulate what this could mean for Thunderdome. From the next report, I expect less of what you can't do and more focus on what you've actually done. Try again, but don't try do.
We made the agents very blunt.
So yeah, just I think you get the idea. So it's the team of agents just simulate the reorganization of with multiple experts, multiple directors, and the teams, and work together. We should generate a very comprehensive, high quality report. And there are many examples, but I will skip that. I will yeah. So I think you get the idea maybe how diverse applications are, and how much like active activities, how many how active the community is, and trying all the frontier things. And another type of effort is to use AG2 to top the very challenging benchmarks, such as Sweet Benchlight, like Voyager and Gaia. I will just mention two examples. One is the software engineering task. Sweet Benchlight is one variation of Sweet Bench that contains real GitHub like bug facing tasks. And I think that in last November or December, the top ranked solution was Global Code Fixer Agent, and it's a very small team in South America, I think, Colombia, I guess, and they were able to build some very strong but cheap agent solution using AG2. They can fix nearly like half of the bugs with just under $1 per bug, and just spend a few minutes to fix them. So it's a very remarkable result. Another example is from the Emergence AI, who built strong web agents that can navigate tasks like shopping online or fill forms for patients automatically. And they also reached the top performance last year. And what's remarkable is that they only use the text-based model, not using any visual capability, but outperforms the previous approach using the vision models. And even today, they're still the strongest text-only solution. Yeah. And I've seen the project about web tasks, so I'm sure you will find it interesting. And they also have open source repo you can check. And by the way, the software testing agent I mentioned earlier actually leveraged that agent E solution and to this automated testing. So we have seen people building on top of each other's work, and it's usually really great active from that question. Yeah. 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 Sure. Yeah. So one thing I found out is the human expertise still plays a very important role so far, I think, in topping these benchmarks. If you have the right human domain knowledge, you often don't need to you do need to design very complex agentic system. You just make the right decomposition and find the minimal number of agents, but the decomposition needs to be right. You need to understand what's important or what makes most sense. After that, just like a relatively simple kind of multi-agent system can already make good progress. And another observation is like a hierarchical kind of agentic planning seems to be a common pattern across several different use cases I've seen. Like agent E is one of them, and immediate use cases is another. They independently came up with this kind of type of solution. Yeah, so this allows us to break down the problems from different levels. There's one agent that understands the most highest level requirements from the problem, and then you can have another agent to generate concrete plans, and have a third agent to perform the execution and follow the plans. I think when we break down into different levels, it helps the agent to focus on very narrow tasks, but easier to test and easier to refine. And then the gather can accomplish more than just having maybe a single agent that's everything. Yeah, so
Hi all.
I guess I don't have time, but I just to quickly mention there are multiple kind of agentic optimization techniques we developed to optimize for different metrics and different optimization choices that solve the big hard problem I mentioned earlier. I think there's also a chance to combine these different techniques into one single solution, and cabinet agent is one of them. It's also a new feature in AG2. This cabinet agent will manage many sub agents automatically and create a team of agents depending on the task dynamically on the fly, and adjust the team when needed, and also add new agents to the library and generate new ones as users use them. So this is also one way to build a strong self-improving agent using the multi-agent as underneath architecture.
Hi all.
So this is just one example of using a cabinet agent in the Wadis interface, and so you can just have tasks like ask a question about a particular YouTube video, and the cabinet will analyze the task and generate several agents of different roles and perform specific tasks, and or select from existing library of agents instead of generating new ones, or assemble tools from an existing library. But eventually, it should be able to like iterate on this task and answer the question. I think the question is asking about one query response for question in the video. Yeah. This is the last slide before I conclude. By the way, if you look at the system design, it's very simple. It's just one cabinet agent plus one user proxy agent. Yeah. So the question was, what is the response after that question, and the agent is able to figure out the right answer. And you see all the other agents were generated during the process, not instead of built from the beginning by the developers. I think that's a promising approach to eventually combine all the different techniques and build a final kind of ultimate solution to solve the optimization problem automatically. Yeah, so we have a large community with more than 20,000 members on Discord, and it's a very open community and welcome all the feedback and the contributions. Yeah, feel free to follow on Discord or other platforms and join our community to build the future of agents together. Yeah, or do research together. Yeah, shall I? Oh, sorry, it's not my laptop.
It's okay. No,
Yeah.
no, it's okay.
Yeah,
All
okay.
good.
Yeah. But,
Just need to stop the recording. Thank you so much for coming.
you're
Akansha.
Akansha, yeah.
Very nice to meet you.
You used to work in Microsoft Research? Yeah.
I used to work in.
Do you
Give me 1 second.
Yeah.
Let me stop the recording.